Data science has been becoming a growing profession and is also the heart of many organizations. That's why Data Science Portugal was born, the first community created by data scientists for data scientists. DSPT wants to gather anyone who works in the field and chat about any topic over this great subject. All members from our team are committed to make sure that the data science field evolves in a healthier and stronger way. To ensure that the focus is on sharing knowledge, we guarantee that our stage is not a place that supports any commercial or recruitment content, and our kind speakers are committed to share their experience for free. We want you. Let's do bigger things together. Join us at any event all around Portugal or online.
Hi everyone, welcome to today's tutorial. My name is Isabel and I have Mario with me. Hey Mario. And you're going to be our hostess for today. So this will be our agenda. Okay. We're going to have the usual opening. We're going to go to our talk by Pedro, followed by Q&A, and then we're going to have our usual networking. So for you guys that do not know DSPT, we are an informal community of data science enthusiasts with the main purpose of sharing knowledge and experience. And in order to do that, we kind of have a philosophy of do's, in which we do promote knowledge sharing, we organize open events, but in order to do that, we also have the don'ts. So if you are having a talk with us, please refrain from things such as selling, so we can guarantee the quality standards on all of our talks. And if you have an idea, if you have a project or anything, please use our call for proposals. We are keen to hearing from you guys. So where can you find us? You can find us in Aveiro, Braga, Coimbra, Lisboa, and Porto, but you can also find us online on our website, datascienceportugal.com, and in all of our social media networks, such as LinkedIn, Twitter, GitHub, and Slack. So do join us, please.
First of all, I want to thank Nós and DevScope for sponsoring this event. If you have any questions during this tutorial, please ask them in the YouTube chat. Keep in mind there is a small delay of around 20-30 seconds, but we'll get your message and will show us as a banner. And Pedro will answer them as helpful as he can. So I want to thank Pedro for being able to do a tutorial for us. Pedro Martins has finished his master's in Aveiro in the course of computer telemetrics engineering. He's a data scientist at New York SCA. He's going to present a tutorial called Managing ML Lifecycle to Mlflow. It's a tutorial regarding Mlflow, a tool that you can use to managing your ML pipelines and lifecycle.
Okay. Thank you for the invite to all the DSPT organization. I'm Pedro. I'm a data scientist, as Mario already introduced me. I'm going to try to do a small tutorial for you guys regarding Mlflow. And I would just like to point out that I hope that at least some of you had already set up the Docker containers that I've published in the DSPT repository because it takes a little bit of time to set them up. I'm also going to say that this is going to be a little bit of a fast-paced tutorial because we have a bit of ground to cover. So I think we can get started then. First, I would like to give you a little bit of an introduction and why you should use a tool such as Mlflow. First, you have to bear in mind that machine learning products are a little bit different than standard software development, as you're probably aware. It does only does not only depend on code, but also on the input data and your model parameters. And the organizations need to version control the data, perform model experiments, constantly optimize the models through hyperparameter optimization, deploy and monitor these models in production environments. So there's a lot to cover. And to all these processes and tools that have been developed in the last few years, we call them as MLOps. The number of tools has been growing rapidly. Mlflow is just one of them. It's just one of them. It provides a set of features for both individuals and teams, and tries to tackle some of these issues that I mentioned. It's also an open source platform that is backed by Databricks, and it works on 4 different pillars. So um, the first one is tracking for querying and recording experiment results. The other one is Mlflow projects, which allow us to create reusable machine learning code and data science code. The next one is Mlflow models, which define a standard format for packaging machine learning models and allowing them to use them in different deployment tools or downstream tools. And lastly, they also provide the Mlflow registry, which is a central repository to collaboratively manage the lifecycle of machine learning models through versioning, state transitions, nodes, uh, and many other things. It provides an SDK in most of the most popular languages on the data science world, such as Python, R, Java, and Julia. It also provides good integration with popular machine learning frameworks, and we're going to look at that in a second. But you have to bear in mind that it's completely language or library agnostic, because you can use also the REST interface that the central server provides, so you can store and query the metadata that you store there. As I said, there are a lot of tools out there that try to tackle the same goals as Mlflow does. For instance, one of them is Kubeflow. It also offers experiment tracking, but it requires a level of DevOps expertise that most data scientists don't have. It sits on top of Kubernetes. It's supposed to be a machine learning tool orchestrator, so it's a little bit different. That's why I said that even though they might offer that solution, it may be with different levels of depth. So Mlflow, on the other hand, tries to be as simple as possible and is perfect for quick experimentation and tracking. For instance, one of the main competitors is weights and biases, which which uses an excellent platform for tracking and reporting. It's one of the best tools for teams that really are focused on research rather than deliverables. It also provides deployment capabilities such as Mlflow, but it's not one of its strong suits. The same goes, for instance, for Comet ML, which excels in tracking compared to Mlflow, but it also lacks a little bit on the deployment and management of the life cycle regarding compared to Mlflow. And besides that, both of these tools are proprietary, so they are paid when they are focused on the business world. So you also have to bear in mind that. Is it perfect? No. Although it's a great tool, it still lacks a little bit behind some of its competitors. For instance, it's not easy to compare different experiments, and we'll go through that in a little bit. And some of the autolog features, although super useful, are still experimental and sometimes buggy. Most of the plots that you can save as an artifact are pure artifacts or not really embedded widgets. The deployment containers that Mlflow creates are far from optimized. They are not 100% reliable, and there are better solutions for that, such as Selden or Bento ML. That one isn't even listed in here. But there are more tools and better tools for this purpose. Finally, there's also one of the features that unfortunately are not available on the open source version of Mlflow, which is the ACL for the model registry. So it works like a pull request where you propose a model um, to be promoted to staging or to production, and an administrator or team lead would approve that request. So that specific feature is not available um, on the open source version of Mlflow. On the other hand, it offers a basic set of features if all you want is experiment tracking, and it provides an interesting set of management lifecycle features, and it's totally language and library agnostic. So let's get a little bit hands-on. For the first experiment, we're just going to create a simple decision tree classifier. So nothing that you probably hadn't seen before. We're going to use the iris dataset as you are seeing. So this is standard machine learning code. You have your hyperparameters, your classifier, your test set classification report, and we also generate a confusion matrix and the tree configuration. So nothing new here, but now if whenever you get to experiment, you're changing hyperparameters, you want to store these things, and you don't have a central point to do that, and that's where Mlflow comes in. So you have a central server where you're going to log every metadata that you create from your experiment. So let's start by doing that. The first thing that we want to do is set an experiment. An experiment is like a group of runs. A run is basically a machine learning training operation. So first, we're going to create here a new experiment, and whenever you set a new one, if it doesn't exist, it's going to create a new one. In this case, it's going to create a new one. And we're going to load our data set, just print here some stats about our data set, check if everything is okay. It looks like so. And now what we need to do to make sure that this data is logged, this metadata is logged into Mlflow, is put every part of our training loop into a with statement, which is going to start a run. And we can name this run, for instance, going to run our first run. Okay. We're going to put all of our code inside our with statement. And now let's start logging. So first we're going to log our hyperparameter list. And for that, we can log a simple dictionary. Then we also want to log some of our output, oops, not in here, some of our output metrics. For that, we can simply create another dictionary where we're going to have, for instance, our accuracy, and we're going to get our accuracy from our classification report. Can get, for instance, the F1 score from our macro average, and I think this is enough for a first approach. We can also set some tags, and a tag is a way of just identifying your run or your experiment. Mlflow provides a set of default tags, and you can check them all in their documentation. They are pretty useful. For instance, you can set your username. I can say, this is my username, just inventing here some stuff. We can also say, for instance, our source is type notebook. And basically, we're just saying that this is going to be run on a Jupyter notebook, but we can also define some custom tags. For instance, can say that our project is our iris test decision tree. And I'm going to show these on the platform. But for now, we can also log our figures. So we want to log our confusion matrix, so any artifact, we can log figures, HTML files, text files. We pretty much have the ability to log everything into the server because it's an artifact. It's a file. It is going to be stored in the run. So that's what we're going to do here. So we're going to take here our figure. This is a little bit of a weird code over here, but we're going to call it confusion matrix.png, and we're also going to do the same for our tree structure, and we're going to call it tree.png. Finally, what we want to do is log our trained model, and for that we're going to use the scikit-learn submodule because this is a scikit-learn model, right, of Mlflow. And as you probably are wondering, there is support for multiple frameworks: scikit-learn, TensorFlow, PyTorch, ONNX. So if you go through the documentation, there are a lot of them, and the most popular ones are certainly supported. If you want to use a custom model, you can also do it, and I'll show that later. But for now, we're just going to use what the framework provides us. So we're going to say that we're logging a model. And last but not least, we can also define the schema of the input and the output of the model. This is going to be helpful later on whenever we want to, for instance, set up a REST API service to serve our model, because we can just provide a dictionary of values, and it will be able to easily interpret those values. And we're going to use here a very simple function that we can just provide our input data frame and output frame, and it is going to infer the columns and the column types of this data. So we're just going to run this. It shouldn't take long. Okay, so it prints here our figures. So now we're going to go to Mlflow, and you can access that through your localhost. I'm not using localhost, but don't worry. Through your localhost 5000 port, and you're going to see that now we have here a new experiment that was the one that we created, and a first run. So this was the run that we basically ran a little bit a while ago. So as you can see, the custom tags that we set up are being shown in here. So we're saying that this is a IPython kernel, so a notebook. This is our source, and our user also shows up in here. So we're overriding the root user. If you remember correctly, we're also logging our hyperparameter list, which only had 2 hyperparameters, our metrics, which was basically the accuracy and F1 score, as you can see over here, and our custom tag, which was our project. And also, if you remember correctly, we logged 3 things, 3 artifacts. One of them was the confusion matrix, which is over here, our tree structure, so we logged 2 images, and also our model. As we have defined that this is the scikit-learn model, it creates a nice structure where it saves the pickled file, a conda YAML file for defining the environment, and the requirement file for the dependency. So you can see over here that we have called pickle, Mlflow, scikit-learn, all the extensions needed to run this. And all of this is defined over here in the ML model folder file, but we're going to go over this later. Let me check just if I have any question here. Not right now. So we're going to move on. Although it provides full customizability and full flexibility to log whatever you want, sometimes it's a little bit painful to do everything by hand. So Mlflow provides a nice feature, which is auto logging. So let's create a new experiment over here. What are we going to call this? Maybe TF auto log experiment. And we're just using TensorFlow so you guys can see that it works on multiple frameworks. And now, for all of this to work, we're just going to enable Autolog for our TensorFlow framework. Again, we need to put everything in our training loop inside a start run statement. Oops. And that is it. Basically, everything that we need to do is already done. But you have to bear in mind one thing. Although Mlflow will log a couple of things into our central server, you might notice, and I'll show that just whenever this is finished, it's still running, that it doesn't log anything out of our feed function. So this is a limitation, or it's done by design, if you can think of it that way, that only the metrics inside the training loop itself are being logged. And you can check the documentation because it's very complete, and it says everything that is logged in every supported framework Autolog function. So you just need to check it. But we're going to check here in our experiments run that although it logged many parameters that I didn't even type, so I haven't defined any of these parameters, everything was auto-logged, as well as the metrics. You might see that the test metrics that we got over here are not being logged, because only those that are defined in here are being logged. On the other hand, everything on your training loop is going to be logged. So every epoch is going to log our accuracy and loss. So it's a good way for you to see if your model is working properly. So our loss is decreasing and our accuracy is increasing. So it seems like it's going well. And we just have 3 epochs, so it's not really to make this fast. I had to reduce the number of epochs, so don't worry that this is a little bit on the small side, but this is just for demonstration purposes. You also see that the the artifact, so the model itself, the trained model, is also being stored in our data folder, and you might see as well that it's a different structure than our scikit-learn model. So it does this everything automatically out of our view. It also logs our TensorBoard logs if you wanted to check this on TensorBoard, and it also logs our model summary. So this is a little bit different from framework to framework, and we're going to see that right away when you're going to use ShishgiBoost, which also auto-logs different things. But the sum of this is that it's going to load your hyperparameter list, your training metrics, as well as your model. This is the base. And we're going to move on exactly for our hyperparameter optimization. You might see that we're using a different framework in here, which is ShishgiBoost, and we're also making use of hyperopt just to automate a little bit our code so that we don't have to create the training loop by hand. We just need to define here the parameters, the hyperparameter search space, and everything is done automatically by the tool. And again, we're just going to create a new experiment by setting up a new experiment. We're going to call ShishgiBoost auto IP test, and we're going to also set up autolog. And as you might wonder, we're doing this before the training loop, because if we want to automatically log the signatures, if you remember, as I shown in the scikit-learn example, we're logging the signature, so it's easier for whenever we deploy a model to create requests to the endpoint. So we're doing that prior to defining the D matrices. So the framework is able to infer the signature. The only thing that we really need to do here is, once again, set up our run, but you may wonder that this time it's a nested run. So we're going to have a parent run, which is our hyperparameter optimization loop. And we are going to have multiple child runs, which is for different hyperparameters spaces. We're going to have a child run. So every combination is going to be a different child run. And okay, I'm just going to indent this. And if you remember correctly as well, we need to log this parameter, which is our F1 score, right? Call it F1 score, F1. Because it doesn't log anything out of the training loop. Now, the only thing that it's missing is creating our parent run. And for that, simply start a new run. And we're going to call it parent run. And we're going to indent this. And I'm not going to run this specific cell because it takes about 5 to 6 minutes. And I've already run it, but you're going to have to believe me that this is working properly. But basically, I've already run this, and you can see here in our experiment that we have a parent run, which has a lot of child runs. I don't know by heart how many there are now, but what we can do is take all of them and compare them to check the performance and to see which one was our best runs. We have a series of plots that we can make to better infer our results. For instance, we can see here that if we compare the call sample by tree parameter with our F1 score metric, we see that lower values of call sample by tree are producing the best results, even though there are here some outliers. But this is the type of correlations that you might see and might adjust your hyperparameter search space. Another cool feature is that we can go here to the parallel coordinates map, and I'm going to take out of here some of the fixed parameters that we're not really trying to optimize. And we're also going to take here the F1 score. And as you might see, the call sample by tree, for the lowest values, we're having the best performance, which is the reddish lines, brownish, reddish. And the same goes, for example, for the alpha regularization parameter. You also see that lower values are producing the best results. So this is also a good way for you to change your hyperparameter search space. For instance, we could just lower even more the call sample by tree parameter search space and try to optimize even more. And I think this is really one of the things where Mlflow is really useful, because you don't have to plot any of this by hand. You just go to the platform, and from there you can take your own conclusions. So now that we have a list of hyperparameters and a list of runs, we're going to take and try to retrieve our best experiment. So if I remember correctly, our experiment is this one, which is the number 8. So we're going to retrieve we're going to search through our runs, and we're going to search through our experiment 8. I could have done a really beautiful method to do this, but I think it's easier for you guys to understand this way, because we're really running the code manually. And we can also order by our metrics, and in this case, this is going to be the F1 score, and we're going to order this decennially, so we get the best results on the top. And if everything goes to plan, we have here our best model, which has 97% F1 score. So now that we have this, we can easily load our booster tree, which is a ShishkiBoost model, if you remember, by going to the ShishkiBoost sub package and loading our model. And for that, we can either go through a run, so we can invoke and retrieve the model from a run, just passing the run ID, and we're going to retrieve the model. And the run ID that we have, which is in our data frame, it's the first index dot run ID. And we're going to have our booster tree. As you can see here, we have here our booster tree. And let's check against our test set again if the F1 score matches. It seems like it. And one of the things that I forgot to show you is that, as I mentioned before, ShishkiBoost loads different things than TensorFlow Autolog does. For instance, we now have our feature importance weight dictionary and our feature importance weight figure. So what we're going to try to do now is try to retrieve this to our local machine. Imagine that you want to do this on your machine learning pipeline. You want to retrieve this automatically. You can do that. For that, we just need to instantiate a new Mlflow client. And we're going to download our artifact. We can download any artifact we want. And we just need to provide our run ID. So all the artifacts are mapped into a run ID. We're going to say that we want the feature importance, was it? Feature importance weight dot png importance weight png, and we're going to download it to our local folder. Okay, so it seems that did correctly. Let's just test it if it's really in here by importing our image loader from, and it's just feature importance png. Okay, so we have it here on our workspace. We've downloaded it successfully, and that's really our goal. Any questions so far? I don't know if anyone posted a question that I did not see. Okay, I'll wait just a little bit because it has some delay. Okay, doesn't seem like it. So moving on, as I said, Mlflow is subdivided into 4 pillars. One of them is the Mlflow projects, which is a way to create reproducible code, data science code for machine learning. And for that, we just need 4 things. One of them is a folder with the name of the project. We also need the definition of a cond environment or a Docker image for the running environment. We need an entry point file, either a shell, bash script, or a Python file, and a ML project file that contains the project definition. So if we go here to our VS Code tool, I have already created this project, so we don't lose much time on this. Takes a little bit to load, but as you probably see here, so we have our train file, which is basically our ShishkiBoost code that I've already showed you. Nothing fancy. The only difference is that now we're loading the hyperparameters through our command line. We have the definition of our cond environment and our ML project file. So we define our project name, and it should match with the folder name. our conda environment through our conda file, and the entry points. So you can structure your entry points by as if they were a pipeline. So we could have multiple entry points. One of them would, for instance, fetch our training data. The other one would do some feature pre-processing, and we would have our main training loop at the end, for instance. And you would have like 3 different files where you would run this. And you can just provide different parameters. In our case, our parameters are really our hyperparameters, which we're going to provide as a command line arguments. And we can simply say that this is going to be the structure, for instance, of our GitHub project. And whenever we want to run this, we can just go here. And I've already stored this in memory, but I'm going to create 2 so it doesn't create any conflict. But basically, we can just do Mlflow run, the name of our project, and we're going to create a new experiment. On your machines, this can take a little bit more to run because it doesn't have the conda environment already set up. I tried to do this beforehand, so we are not waiting for much. And you're also can just go to our Mlflow platform again. We're going to see that we have our test experiment. And the only thing that you're going to notice is that we now have here our run command. But we can also change our hyperparameters. So we can, through our command line, we can say that we want our max depth parameter to be 7, for example. And if you notice, in the previous run, our max depth was 4. And on this new run, hopefully, it will be 7. So imagine that you have an automated CI/CD pipeline, and you would just take this command and run it on the pipeline. So you're not losing much sleep over this. And you can also check that hopefully, yeah, max depth is now 7. So Mlflow in the end provides a really nice way for you to structure your projects. Of course, you have total flexibility to do this as you and your team decide, but I think it's a good foundation of how to really structure your project and automate and make sure that the environment is not machine dependent. As I also promised to talk about Mlflow models, so this is a standard way that Mlflow provides for packaging machine learning models, and so that they can be used in a variety of downstream tools. So you can use them to run them locally. You can use them to deploy them through a real-time REST API or through a batch inference job in Spark. So the idea here is to really define a convention through different flavors. And what is a flavor? So if we go here into our ML model definition, you're going to see that we have 2 flavors. So one of them is our ShishkiBoost flavor, which was the one that we used. So basically a booster object of the ShishkiBoost class. But we also have a Python function. So a Python function here is basically a wrapper around the ShishkiBoost object that Mlflow automatically creates, and it depends on the conda environment defined here. So these files are automatically created by Mlflow whenever you log an artifact. And basically, you can retrieve either the Python function or the ShishkiBoost function. And you can also check that the loader module is exactly a class that defines the wrapper. So we're going to do that. If you remember correctly, and I don't know if a question popped up in here, I heard the sound. Maybe I was wrong. Okay. If you remember correctly, on the top, we loaded our booster tree using the Mlflow ShishkiBoost submodule. So we're really using the ShishkiBoost package. Whenever we want to predict, we need to use the D matrix. So it's pure ShishkiBoost. if we want to use our Mlflow Python wrapper, it's very simple. We can just call it by, instead of using our boost, we're going to use our pyfunc load module. And the rest is exactly the same. So we're going to fetch our run from our data frame, which has the best runs. We're going to fetch our run ID and our model. So this is exactly the same. And we have here our booster tree, now wrapped into a Python model. And we can also predict, instead of using a D matrix specific from ggBoost, we can just provide a dictionary that was defined by the signature. This is very important to remember, that it's really correlated with the signature method that we seen before. And here we have our petal width, and we can 2, this is going to be 3, this can be a 1 as well. And this is our petal length and our petal, oops. And you can see now that it returns already an NumPy array. And we didn't have to convert this into a D matrix. This is the cool thing about Python functions. Even though they introduce a little bit of a overhead because it's more code, it's cool because it provides a unified format for any machine learning model that you have. But you can also define your own custom models. So it's, if you find yourself in a situation where you don't have support for your custom model, or your I don't know, a new framework that is still not available on Mlflow, we can provide and create your own class model. So we're going to create here a custom model, but this is not really a machine learning model. This is just a model that is going to add an n to the array that we provide, the data frame that we provide as input. This code is also available on their website, so it was an example really copied from them. But this is a good way of presenting this feature to you. Basically, we just need to import our Python model. So we're going to create a class extending Python model. We're going to store our n, and we're going to refactor and our predict function, overwrite our predict function. And to do this, we're just going to apply and increase this by self.10 for every column that we have. Okay. And now we're not even going to log this. We're just going to store this locally, because I don't think it's necessary for us to log this into Mlflow. You can also store all of them locally. And we're going to add this. I'm going to add 10. Thinking about 5 initially, but 10 works as well. And we're going to save our model into model path, and we're going to say that our model is exactly our add 10 model. So this is going to create a new folder here, add a model with your model, exactly like it's stored in here. And we can just test it. So this is supposed to go from 10 to 20. Okay. It seems like it does. If we check our model output, we're going to see, that it's our model input plus 10.
Sorry, Pedro, we have a couple of questions.
Okay, yeah, for sure.
Sure. So this is the first one from David S. Hi, Pedro. How can we integrate auto log with custom logs?
Yeah, this is very simple. Is just as I exemplified in scikit-learn. So you can just turn on autolog, and then you can just use the log model or log metric or setx, any command that you have available on tensor on Mlflow for you to log information. You can use it at the same time as autolog.
Okay, and the second one is also from David S. How do you use Mlflow for managing individual research experiments?
Yeah, there's not really a need for a shared registry. You can just it's basically keeping a copy of everything you do. I'm going to go through the registry a little bit more in detail in a second, because what we were looking to was the experiments part, not really the registry. The registry is more for you to manage deployments. But you can also run Mlflow locally. You have to bear in mind that the Docker setup that I provided to you guys has multiple containers, because for us to use the registry capabilities, we need to have a separate, how's it called, artifact store. So it's not just going Mlflow server and it works right out of the box. That specific feature. So for tracking an experiment, yes, you can just have your local server and it works flawlessly.
Okay, thank you. If there are more questions, please ask them and we'll show them. Okay, thank you. Continue.
Thank you. Okay, so the last part that I really want to show you is how to manage machine learning lifecycle management. As you may wonder, we still haven't peeked here into our models section, because this is really the deployment management part. For that, you need to register a model. So that's what we're going to do. We're going to take this model here and we're going to register. In this case, we're going to create a new one. Going to create test, boost model, and we're registering this model. If we're going to check this, we now have a model, and contrary to experiments, we now have a registered model. So it's like you have all your models that of your services listed here in our registered models, and you can manage the life cycle of each one of them. You can log versions, so you just take your run and register a new version, or you can promote your model from, for instance, version 1 to staging and from staging to production. So that's what we're going to do first. So imagine that we have here this run, and version 1 is tightly coupled with this specific run, and we can edit our description, say this is the first version, please check the results and review them so that a colleague can look at this. Obviously, this would be great using the ACL version of Mlflow, but unfortunately, that's not available on the open source one. We can also check our input data definition and our output data definition. And we're now going to promote this version 1 to, let's promote this to staging. So what we see is that now we have our version 1 promoted to staging. Let's grab another ggBoost example, and it can be this one, and we're going to register again. And bear in mind that you can also do that through the API, so it's not mandatory that you use the user interface. I'm just doing this using the user interface because I think it's easier to comprehend. And we can reuse the model that we have already registered, and now we register v2. So if we go to models, we're going to see that the latest version that we have available is version 2, but it's not promoted to anything. So let's promote this one directly to production. So now we have two versions, one in production and one in staging. But let's just imagine, and this doesn't make much sense because version 2 is going to be depromoted, as you're going to see, and version 1 is going to be promoted to production. So whenever we go to this and we decide, so now we're going to promote this model to production because we've already A/B tested this and we're now ready to put this in our online services, we can just go here, transition to production, and if you check this warning, the models that are in production right now are going to be archived. And that's exactly what's going to happen. So version 2, that it was on production, it's now archived. And we can simply think of a very simple scenario for this. So imagine that you have a deployment container where you're going to fetch once a day the production model. So you don't really even need to change that container. So you would just fetch the production model, and we're going to see that right in a second. And it would automatically download every day the new model. And if you don't change the model, it's going to download exactly the same. But if you do, it's going to fetch the new one, and you don't even need to change the container because everything that you did was changed in the central Mlflow server. So now let's try serve. I think it's serve. No. Yeah, I forgot the models. Let's serve our production model. So it's called GHGBoost test GHGBoost model. So we just need to tell the name and the stage that we want. We can also use the version. So it's not really mandatory. Action. It's not really mandatory that you use the stage as a name. You can use a versions. For instance, we could just do this one and delete the rest, and we would get version 1. But for now, we're going to use the production one, and we're going to serve this on port 1234. It's going to create a Flask web server. Oops, okay. Let me just delete this because autocomplete is completely screwing this. Models serve models GHGBoost GHGBoost model, and we want the production one, and we want this on port 1234. Oh, come on, so many typos. If everything goes to plan, it's going to create a REST API for us to fetch data from there. And I just have here, here a small example for us to, I forgot to import this, for us to invoke the endpoint. So it's also going to expose a new endpoint where we can fetch the results of an inference. And we're just passing the sysTest xtest data in a JSON split format. You can see all the available formats in here. It's not really recommended that we use this one. You can check this on their documentation, but we can also pass in a CSV and it will work fine. As you can see, we have all our inference output in here. So it worked flawlessly. One of the concerns, and this one I've already shared with you before, is that the inference containers that Mlflow provides are not really optimized. So sometimes they have some downtime because they are based in Flask. It's not really 100% reliable. Something like BentoML or Selden would do a much better job in this, and you can easily integrate this with Mlflow. I'm not going to show you, but I'm just going to show you that you can basically fetch any model that you have. And it was not model name. I didn't define model name up here. Maybe not. So yes, boost model, and we're going to see that we have listed one model in production, and it's version 1. So as I was saying, you can integrate Mlflow registry with any of these tools like Bentoo or Selden, and it would create a much more robust serving system. So I would suggest for you to use something like Mlflow to manage your experiments, to manage the lifecycle, but then to not really use the containers they provide for deployment. You can also, for instance, deploy a model directly to SageMaker or Azure ML. Mlflow provides an interface for that, but as I said, the output containers they generate, I wouldn't say they are completely appropriate for this. And yeah, thank you very much for your time and your attention. I know it was a little bit of a fast-paced tutorial. If you have any questions, please share them now. I'll gladly try to answer them. And yeah, thank you.
So if anyone has any last question, please write in the chat so I can share with Pedro, and Pedro will answer it.
And in meanwhile, I would like to thank you, Pedro, for the tutorial. I think it was really insightful, and we're already having some questions arriving in the channel.
Yes, it is. They have a managed version, which has some additional features that the open source one doesn't have. The one that I mentioned, the ACL, which is really useful, it's only available on Databricks. They were the ones that contribute the most to this open source platform. So yeah, it's available over there.
We have at least another question from Miguel. Anything you dislike about Mlflow?
Yes, as I said, the deployment containers are not that great. There are better solutions for them, and also the integration with some of the artifacts, it's sometimes a little bit disappointing. As you saw, the pictures sometimes get a little bit blurry. Something like Comet or weights and biases have really a good integration with the plots. They just get the data and they create the plots themselves. Or they have something like Plotly working on the background to improve those. So if you really want to use a platform that is really geared towards researching, and you have the budget for that, obviously weights and biases and Comet is the way to go. If you want to keep everything open source, if you want to keep it language agnostic, which the other two aren't, if I'm not mistaken, yeah, I would advise you to go with Mlflow. One other thing that I really dislike, and I'm forgetting, is that sometimes the Autolog integration is kind of buggy, and you really have to mix and match the versions of your frameworks for this to work properly. Sometimes a little bit of test and error. So I had that problem setting up the tutorial with TensorFlow because it was not logging the artifact. So that's one of the pain points, I would say.
So, last opportunity to make questions for Pedro. We have another one. Is it easy to integrate Mlflow with TensorFlow and PyTorch?
Yeah. I mean, if the autolog doesn't work properly, you have to do it manually, of course. But if you use a compatible version and they have that in their documentation, it's pretty easy to do it. You just set up autolog and it will work flawlessly. You just have to keep in mind that your test metrics have to be logged manually, because anything outside the compile and fit cycles is not being logged. But other than that, you can use this with pretty much anything. That's why I said it's really framework agnostic.
Again, last opportunity for a couple of questions. Don't be shy.
And we have another one. So how can we solve the problem of lack of authentication for each project?
I would say that you can go in either one of two ways. So you either set up multiple Mlflow instances. That's a possibility, which is not really a big overhead, because if you really think about it, it's a really small framework with a very small footprint in terms of runtime, and you can have multiple ones, and you can do the authentication management through an Nginx proxy, for example, or you can take maybe the harder route that would be to create a plugin, because Mlflow supports plugins, and do the changes yourself to make sure that you can have an authenticated system. But I would say that's a little bit more tricky, and it takes a little bit more time to do.
Okay, thank you, Pedro.
Thank you as well.
Last minute. It's last minute for questions.
It's the Black Friday of questions.
We have another one. Have you tried data version in Mlflow? Set version parameter resolution?
I've never tried it, but it's possible. For instance, you could log specific parameters regarding your dataset. It's also a good way for you to discover if you have any data drift. For instance, you log more or less the description of your feature distribution, means, averages, standard deviations, percentiles, and this way you can have it backed up in some place. And imagine that you have an automated machine learning pipeline where you have this always logged. You can check against the model in production, because you can retrieve all the artifacts and all the parameters of the models that you have in production, and you can check against that if the data set has any drift. Obviously, it's not really data versioning, because you're not versioning the data itself. You cannot retrieve the old data that you used, but it's a way of logging metadata about your data.
Okay, thank you very much, Pedro, for your kind presentation. I think it was helpful and people really liked it. We have the last bit of slide before the networking. So if you have any work, any tutorial, any presentation that you want to make within our community, feel free to contact us, right? You can use this link, this QR code, and we'll evaluate our proposal, and we'll give you a stage where you can share what you have been doing in the field. So don't be shy. If you have anything that you want to contribute or share with the community, please talk with us. I want to thank Pedro for the nice presentation. I want to thank you all for being here and engaging in this community. And I want to thank the sponsors, DevScope and Noj, for sponsoring this event. I hope to see you soon in the following event. And we have a small networking that will also be done remotely. I think Pedro will be there, and you can continue to ask questions regarding Mlflow and his life as an ML engineer in a company. So thank you all, and see you in the following event.
Thank you, guys.
Data science has been becoming a growing profession and is also the heart of many organizations. That's why Data Science Portugal was born. The first community created by data scientists for data scientists. DSPT wants to gather anyone who works in the field and chat about any topic over this great subject. All members from our team are committed to make sure that the data science field evolves in a healthier and stronger way. To ensure that the focus is on sharing knowledge, we guarantee that our stage is not a place that supports any commercial or recruitment content, and our kind speakers are committed to share their experience for free. We want you. Let's do bigger things together. Join us at any event all around Portugal or online.